This video is for section 13-3, Applications of Arithmetic Series. How much did an engineer with Fairfield Aircraft earn in 10 years if his starting salary was $54,000 and he received annual increases of $2,500? We're asked to sum up the total amount of money that this person got in 10 years. So we're looking for a sum of the sequence of salary values each year for 10 years. So the formula we might choose is n over 2 times 2a plus n minus 1 times d. In yesterday's lesson, we actually had two formulas that we could use to find the sum of an arithmetic series. But the other formula involved the first term and the last term. In this problem, we don't know how much the person earned in the 10th year. We could figure that out, and if we did, then we could use the other formula. But I think this formula will be faster because we do know the starting value and we do know the difference each year. So we want to find the sum of his salary for 10 years. So n is 10. The letter A in the formula is the first term in the series. That's $54,000. Again, the letter n is 10. And the letter D is the difference between terms. In this problem, that's his annual increase in salary, $2,500. We make those substitutions and then figure out what the right side of this is equal to. So the sum after 10 years is equal to $652,500. Next example. There is a game that's played with matches. The object is to avoid picking up the last match. 4 rows of matches are placed on a table. If the number of matches in each row are consecutive integers, and the second largest row has 6 matches, then how many total matches are used in this game? Let's sketch what this is talking about. We have 4 rows of matchsticks, and the number of matches in each row are consecutive integers. The second largest row has 6 matches. So I'm just going to draw lines to be the matches. Here are 6 matches, and that's the second largest row. So the first largest row would have one more than that, 7 matches. And because they are consecutive integers, the third row and the fourth row can be figured out. This one has 5 matches, and this one has only 4 matches. To find the total number of matches, add up the lines. This is 7 plus 6 plus 5 plus 4, 22 matches. Next example, find the sum of the first 1,000 odd numbers. For this problem, we don't want to approach it like we did the one with matches, because if we were to actually draw this out, we're going to have 1,000 numbers to add together. We don't have the time to do that. So this one we want to do by recognizing patterns. The first odd number is 1, the next odd number is 3, then 5, then 7, and so on. This is an arithmetic sequence where the difference between terms is 2. We also know the first term is 1. So let's use the sum formula for 1,000 terms, where we know the first term and the difference. So that formula is n over 2 times 2a plus n minus 1 times d. For the letter n, we're told we have 1,000 numbers. For the letter A, our first number is 1. For the letter D, the difference between terms is 2. Now evaluate what this is equal to. This adds up to 1 million. In this lesson, we did a few examples from the section, which is about word problems involving arithmetic series. If the problem is about summing up terms, then use one of your two sum formulas. Either the formula where you know the first term and the last term, or the formula where you know the first term and the common difference.